Hello, good morning. We have been talking about triangles. We have one more result regarding a triangle which we shall do with the help of models, and that is the midpoint theorem for a triangle. The midpoint theorem says, as we know, you take any triangle, take the midpoints of two sides, join them, and this line segment that we have got now will be parallel to the third side and half of it. Okay. Here's the model for it. We have a triangle. We have taken three midpoints. We need only two, but we have taken the third one also. As we shall see, it has some significance. And we are interested in this line segment. So we have cut it along that line segment. Along this line segment, we have cut the triangle into two parts. Now you can see that this is a triangle, and if we take the third midpoint which we haven't used, join it with the other two midpoints, you get three other triangles. And what is so special about it? Immediately we can see that these two look very much alike. In fact, they are congruent. So also these. Oh, so this is the only odd man out. No, it is not. Because suppose I take this triangle and rotate it, you will see that it fits in exactly. This is also congruent. So we have divided the triangle into four congruent triangles. Now, half the job is done. We wanted to prove that this line segment is half the third side. We have already seen that these two are equal, and therefore this line segment here is exactly half of the third side. Okay, fine. Now, the angle, the parallel. How do we show that they are parallel? We shall use the fact that if two straight lines are parallel and a transversal cuts them, we take any two straight lines, and if a transversal cuts it in such a way that the corresponding angles are equal, then the two lines are parallel. Now we want this parallel to this. We shall look for corresponding angles. We already have a transversal here. Are these two angles equal? Let us say yes, because they were congruent. So this angle is equal to that angle, and you can see that it is right here, and so these are corresponding angles, and this line segment will be parallel to the base. That finishes it. It's so simple. Now we are going to talk about another very beautiful property of triangles, but not with models, with another interesting method which we have seen last time, paper folding. And the result that we are going to talk about is this. Suppose we have a triangle. We can take the midpoint and join it with the opposite vertex. We call this a median. Now, how many medians are there? One from each vertex onto the opposite side. So we have three medians, and the result says that the three medians are concurrent. Now, that's not all. You take any two. Now we take the angle bisector of a triangle. How many do we have? One for each angle. There are three of them. These three are also concurrent. Okay? Anything else? Yes. Take the altitudes. We have three altitudes, one from each vertex onto the opposite side. All three of them are concurrent. And still, the last surprise is that if you take, this is the midpoint, know, we call this the perpendicular bisector of the side of the triangle. Each side has a perpendicular bisector. There are 3 of them. These 3 are also concurrent. So that is the beauty, that not only the medians, angle bisectors, all 4 of them, altitudes and perpendicular bisectors of all 4 of them have this concurrency property. Alright, we shall try to show that by paper folding. But one thing we want to do before we start with the paper folding is, let's suppose we have to use it here. See, we have to have we are going to use only paper folding, no drawing, no cutting. So we will need a perpendicular from a point outside the line onto this line. That we will see how to do it. And another time, second time we will need on the same line, on another line, a perpendicular from this point on the line. This is a perpendicular outside, from a point outside the line. Okay, what we do is, I have taken a point here. This is my line. If this is the point, I have to fold it at this point, and in such a way that this part and this part, they coincide with each other. For example, I will not take it like this, but like that. And then I press the fold, and this is the perpendicular from this point to this line. Now I take a point on the line, and I want a perpendicular to it. So fold it at this point, same thing again, the 2 must coincide, and press it. And here is the perpendicular to the line at a point on it. Now that we know how to do it, we check the results for the triangles. Now here is a triangle, and we want to know or verify whether the medians will concur or not, they will be concurrent or not. To take the median, I will show one and the others will be quick. We will first take the midpoint as we did last time, and then from this midpoint I am still not folding. I have to fold in such a way that my fold goes through that vertex, and so now I will press it. Similarly, from this point I have to take a line to this midpoint, and that is this. Now as you must have seen, this is the third point, the third midpoint, and the third median. As you must have seen, I have pre-pressed all these so that I don't spend much time, because this is a very time consuming thing, because you have to be very precise and very patient. While folding like this, if you fold even slightly off, the result will not work. Well, okay, now let's see. We have the 3 folds, and you can see that this point lies on all the 3 folds. 1, 2 and 3. Meaning thereby that all the 3 medians are concurrent. Now angular bisectors. For angle bisector, we want these 2 angles to be equal by folding it. So we fold in such a way that the 2 sides of the triangle will coincide with each other, and now then what we have at this fold will be equal angles. So now we press it. The same thing here for equal angles, and again for equal angles. And now you will see that all the angular bisectors, they meet in this point. Now this is for altitudes. I have drawn that in pen, assuming that it means the fold may not be clearly seen, but it can be seen, so it's alright. Next time we shouldn't do this. We want altitudes, so perpendicular from a point outside to the line. The point is here, and I want the perpendicular on this line. So now I will fold in such a way, not any way like this, but it should fall exactly here, and then I will press. Similarly for altitude here, hold this, fold here and press. For altitude from this point, hold this, fold this and press. And now you can see that the three are concurrent. Same thing with perpendicular bisectors. First you have to take the midpoint, and now it's easy because you already have the point here, you have already coincided these two lines, so fold it. Similarly, to get the midpoint here, we have done this already. We have got the midpoint and fold it, and same thing here. And we can see here now that first, second and third, all the folds pass through this point. So the perpendicular bisectors of the sides of a triangle are also concurrent. The only thing is that there is a small catch. If these triangles are all, these are all acute angle triangles. If you take an obtuse angle triangle, there will be a little bit of problem, and the problem will be not for medians, because the medians will always intersect inside. Angle bisectors will always intersect inside. But what happens if you take an obtuse angle triangle? Here is an altitude. This is fine. But now if I want an altitude to this, I will have to take it somewhere here. And an altitude to this will be somewhere here. Well, they're not concurrent. They are, we don't see them. You can see that they are all concurrent, but they are concurrent outside. Same thing will happen with perpendicular bisector of the side, and therefore if we want to do this by paper folding, we cannot cut the triangle because the point of concurrence is to go outside. We take the whole paper, draw the triangle, fold, and we shall see that the triangle remains here and your center of concurrence, it will go somewhere outside. Well, I hope you will cut out several different types of triangles and try these things yourselves, because just now you might not have been able to do anything, just watch. So try to do it yourself, but be careful, be very precise, be very patient. And then you will have very good results and you will have fun. So best luck. Thank you.